Hello friends. Welcome to YouTube learning channel. Accurate. ASME. ISO. This video is clarifying you the difference between flatness and parallelism. You will certainly enjoy the video with simple and animated presentation. Please do not forget to subscribe and like with suggestion for next videos. Let's begin now. Flatness is the condition of a surface or derived median plane having all elements in one plane.
Now let us start the practical measurement on 3-coordinate measuring machine on a demo component. Let's start the software ARCO CAD. Once you click the icon on the screen, it would display starting the ARCO CAD software. The main screen is appeared. From the File drop-down menu, select New Project. In this case, you are asked for the existing project to open or give a new name for the fresh new project. Once the project is selected, either new or existing, the prerequisite command lines are appeared. As well, you have to select calibrated probe. Then click on the measurement icon of the plane measurement. Once the icon is clicked, software is asked to measure the points with joystick. It includes automatically the program lines addition in the program window. Total 15 points are probed. Once you say it is OK, then it shows the actual values X, Y, Z, I, J, K and the form. Here form is the flatness. You add the nominal value as well. Now the program is ready for the CNC use. This is a CNC program where all the points which are programmed are repeating. These are the controlled movements for the better readings. Flatness is clicked, tolerance is given, and which plane, form or flatness is required. Selected, evaluation is done, and you got 6.1 micron as a flatness. So the component, when you have placed in a normal position horizontally on the bed, the flatness is measured 6 microns. This is the condition where we have to check whether flatness value or the form tolerance varies by tilting the components. So you would see here the same component, instead of normal placement horizontally, it is given a tapered angle so that the component is looked in this fashion, inclined in the bed. Then the same kind of the program and the probing is followed. So you would see the measurement is being carried out on the same surface, but orientation of the surface is changed in the second time, with which what is the objective to understand? We want to understand whether the plane having a certain flatness value, if measured in any of the orientations, the flatness value is changed or not. Normally, we understand all the form tolerances never changes or doesn't require datum surfaces. They are independent tolerances. So this is a practical example with which we can understand in the tilted condition and horizontal conditions if the data varies. So This is getting measured. The top surface at certain angle, approximately maybe 25 degrees, is good enough to understand. And the same kind of the probings as in the previous measurement carried out is also carried here. So let us look at the measurement window of the ARCO software. Click on the flatness. Again same window, put the nominal value. Then select the plane number for which you are asking the flatness. Expanding, then second plane, and say evaluate. Now let us see what is the tolerance. Yes, so you would see exactly the same 6.1 micron. Again, tolerance value is shown for the flatness. So what is the outcome here? Our objective was the flatness never changes with the datum or the orientation. Or we can say for the form tolerances, no datum is required. So on CMM, definitely you can put in any of the orientation having the good access of the probing. But in case of the conventional measurement, you have to take care that though you are not considering the datum, but on the same time slope error of the measurement is to be removed, which we have better understood in the previous video of this flatness. Okay, now let us do the measurement of parallelism. Here it goes. So the parallelism we want to check. For the parallelism, as we know, datum is important. Number of points are getting probed on the top surface of the component. Total again the 15 points. This time the flatness shown is 7.7 micron. If you want to put in the report, you can select the flatness, or if you want to calculate the parallelism. Now in this condition, the part is flat and the plane, the old plane 2, which was measured as an inclined way. So let us see what the parallelism is seen here. Tolerance zone you can put as per your drawing specifications. Here we are just put for our learning purpose. And again, as datum is selected and the value measured is 152 micron, 0.1521 millimeter. So the bottom surface and the surface of the top component. Now what we carrying the exercise here, we want to check whether parallelism is affected if the part is kept tilted and we are taking the bottom surface not of the component but of the simulator. Datum simulator is the condition when you cannot probe the direct part, then you have to put on some master surfaces, like in this case granite plate or a good holding plate, as you have seen the black surface plate. Okay, so first the top surface is measured. Here again 6.2 micron is the flatness we see. The same component, the same, so very well repeatability. It is individual surface flatness, no reference is required. Then for the parallelism, if you select the datum, you select it the datum which is the plane and the tolerance element of which you want to select parallelism. Again some value about the parallelism, 150 just for our information, and you click it, evaluate one more time, and you see the parallelism is 4.9. Why it is? Because the bottom surface or total component oriented at certain degrees with respect to the bottom, say datum simulator surface, and that datum simulator is at inclined, so the value is changed. What is the conclusion? The conclusion is for the flatness no datum is required, but for parallelism datum is important. So readings would change according to the angle between the two surfaces. So how to summarize the flatness and parallelism? Flatness of the top surface in normal rest of the part we have measured in 6 micron. Flatness of the top surface in orientation rest of the part again is the 6 micron. So they are independently verified. Flatness of the datum surface independently checked is of 13 micron. But parallelism of the top surface with normal rest, it shown 150 micron, whereas parallelism of the top surface with orientation rest of the part, it shows around 4 millimeter, 3 millimeter like of the values. To sum up, form errors, no datum is required, whereas parallelism requires.
Hope that you have liked this video, with very easy and simple explanations. You can comment how do you see this initiative and suggest more on upcoming videos. Also we are pleased to conduct training programs at your locations in factories. We offer ARCO Germany, an international CMM certification course. Basic of GD&T. Advanced GD&T. Stack up tolerances. Surface finish. MSA and other quality tools. For further details, please contact us. And I'm sure you will encourage the initiative of training through YouTube, by subscribing a channel. Accurate, ASME, ISO. Thank you and have a good day.
नहीं होंगी तो उसको कट करके